Okay, let's solve this. So they had given uh, what basically they're asking is, so we have to find the most competitive subsequence. What a competitive subsequence is. Suppose uh, there are two subsequences. In these two, the most competitive subsequence is 134. Why? Because here 1 is equal, 3 is equal, then by comparing 5 and 4, 4 is less than 5. So the one which is lesser is called the most competitive. So yeah, in this case of length 2, and these are all the subsequences of length 2. So here, what is the most competitive subsequence here? So there is 2 comma 6, that is the answer. So we have to store the answer as well. So what I'm thinking here is, so is it streaming? Yes, it is. Okay. Mm, so I would use DPFI, and like two-dimensional DP. So index of that subsequence and j is the length of that subsequence. So DP of ij stores the most competitive subsequence starting from I and is of length j. How I can use this in other calculation? Like what is the transitive relation between them? So yeah, now comes the real thing. So rather than, so yeah, I comma j is required, I guess. Now how do I solve that? Hmm. So given, like, let's see the examples and all those things. By just seeing acceptance is 52.3%, that's actually good. So am I missing something? Is it not DP? So yeah, let's see. So immediately what, by seeing this example, what I thought was, so just take the first minimum element, then after that, by taking the first minimum element, then consider, like, then take the next minimum element from that. But in that there is a problem. So what if the first minimum element is at the last index and then k is 4, but I would not possible to do the 4 size index like subsequence, right? That is the issue. So I was thinking greedy, but like, how do I do that? So nums is 1 if that's, yeah, that can be done in of n log n. So of n log n is the maximum. So I guess then it would not be. So I think DP way is not suitable. So then how can I do it? How? So for an index, what if? So there is 3526 k is 2. For index, what if I store the next minimum index, like next minimum, so whatever it can be, right? 3, after that I can get 2 as this k. So here, so 3 5 2 6 here, if k is 3, then the element would be 3 to 6, right? So for every element minimum, like, yeah, for every element I should take the next minimum element, among the catch here is, so if I take the next minimum element, yeah, how can I do that, man? So let's see the hints. Stack, yeah, monotonic stack. Okay, monotonic stack. I was thinking, so let's keep this the DP way like that only. So as monotonic stack, it is for every element, what if I take the next minimum element to its right? So, okay, if I would make that element, okay. So, now what? After, let's suppose the array is 3, 5, then 2, then 6. Then what would be the, like, what? Hmm, What would be the, like, next smaller element to its right? For 3, next smaller element is 2. For 5, that is 2. For 2 is none. So I would make, so denoting that there is no elements. So for 6, what is the next one? That is 4. So once I build the next smaller elements to its right, how can I solve this? Like, as the given index is 4, right? Like the k, given condition k is 2. So how can I make things work? Right. Okay. Ideally, the best case would be taking the element from which is the minimum possible, like starting the element which has the minimum possible thing. So how can I do that? How can I do that? None are watching my streams. It's okay. How can I do that? What if I come from last? So that is 3, 5, 2, 6. What if I come from last? So 6 is there. If I get 6, then yeah, I can either add it to my subsequence or leave it. So I will choose, I will add it as well and leave it as well. Okay, then comes 2. Then I will add it 2. So once the size is 2, what I should do? So it can be a possible answer. Possible answer. I don't know whether it is the most competitive one, but it is a possible subsequence. And then either I can add 2 to this 6, or I can add 2 to the previous thing, or I can leave the 6 like that only, or I can add 2 for the new thing. So yeah, these are the things are there. Like for 2, I can add it to the pick, or I can add it to the not pick. Right. Mm. So for 6 it is either add 6 or neglect 6. So now for 2 I can, so let's make it 3, 5, and 2, then 6. So first thing is add 6. So or continue. So that becomes empty. Now initially the 6 is there. What I can do for that 6, I can add my 2 like that. So this will be for that one thing, like not adding case there will be 2 or there will be empty. So yeah, but is it feasible? So yeah, this would be one of the probable solution, but is it feasible? Like for every element, there are four. It would be of n factor. For every element, there are n number of choices. For n element, n number of choices. That's not n square. For every element. So no, for two elements, there are four choices. So for three elements, there are 3 to the 6 choices. For four, so like this, it becomes exponential. So yeah, it's n factorial for sure. But I should not have n factorial. Can I somehow modify this thing like not using all the things? Topics, array, stack, greedy. Okay, greedy. Uh, so if I take 6, okay, uh, this is the recursive way. But how to make it as a greedy way? Mhm. In lexicographical order, the elements to the left have higher priority than to the. So, can you think of a strategy that incrementally builds the answer from left to right? Okay. So, I was thinking the wrong way. So, from left to right, it is. Okay. Ideally, for any element, if I want to make it as the starting index, so for k subsequence elements, the elements there should be at least k minus 1 elements to its right. So considering that as the thing, how can we solve this problem? So as they are saying it is greedy, hints are that it is greedy. Like what if I add all those elements in the priority queue? So yeah, that is not feasible, I guess. So because this is a subsequence, so when I traverse from the left to right, so that is 2, 4, 3, 3, 5, 4, 9, 6. First is incrementally building, right? So I get 2. First I will add. Okay, yeah. I think I got it. First is 2. I will add it to the answer, my answer, right? Then, then comes I will check. So there should be a base condition. Like there should be a condition check. Go till size minus k minus 1 elements to check for the first element itself. So this is the thing. Like first I would add 2 to my array, then 4 comes. Okay, then 4 comes. So 4 is ideally I can. So first element is 2 itself because 4 is greater than 2, so it will be not the most competitive one to add it to the array. So, but ideally it can be added as a second element, right? Right. So then comes 4. Okay. Uh, Now comes 3. So I still have so many choices, right? To add it. So what I would do? So usually 4 is greater than 3, so I would